This is Gaming AI Uncovered. My name is Paul Roberts, and in this video we're going to be looking at intelligent cover. But before we do though, we're going to take a quick look at how you would normally look for cover in a game. Say we have an open environment that just has one object we could use as cover, and our agent is positioned off to the bottom right and our enemy to the top left. To use an object as cover, it will usually have points of cover. There can be as many or as few as you need. For this example, they will be at each edge of a corner and in the middle of the longest sides. To determine if an enemy can see a point of cover, it needs to cast a ray towards the point, checking along the way to see if there is anything blocking its view. This can be an expensive process, and it has to do that for all points it can see, and all the points that are kind of half in cover, and the ones it can't even see. Remember, it doesn't know what it can and can't see until it does this. And the problems get worse when you have multiple enemies, because each of them has to do the same checks. Now imagine if there was another object that could be used as cover, and another. You can see how this can quickly become a problem. But that is not the only issue here, because our agent needs to do something similar. Wouldn't it be better if our agent could just check which objects are in range that could be used as cover, and then get the best point of cover from the object? Or the object itself rates the points of cover based on safety and returns those to the agent, so the agent can decide which one to use. Well, that is what intelligent cover will do for you. But first we need to look at the concept of octants. So let's go back to our single cover object and add 8 segments that reach out as far as a preset radius allows. This is how far the intelligent cover will look for enemies. Intelligent cover also uses a close by radius too, but for this video we'll just be looking at the far out radius to keep things simple. And for now we're going to remove the points of cover. We'll come back to them soon. Right, so each octant has a score. This is set to 0 by default and reflects it as being a safe octant. However, if our enemy moves within range, then the octant it is within gets a score set to 1. This means it is visible. We can then set its neighbours to visible too. With this information, we can then set those octants on the flip side as safe. But things are never that simple. There's a chance that the enemy can see into the octant opposite to the one it is standing in, so we mark that as being at risk. So if we remove the octants already classified, it leaves us with 3 octants. These can be given a score of 0.5 to reflect their ambiguity, but why does any of this matter? When you pathfind through an environment, the objects used for cover are treated simply as obstacles to avoid. And like you can see in this example, at this point you will have run into an enemy and have had to handle that situation. Well, if we start again, and this time use intelligent cover, the octant scores can be used to influence the pathfinding algorithm and our path becomes somewhat safer. But let's get back to those points of cover. Using the intelligent cover we've just created, we can set the points of cover within octants that are visible to also visible. Remember, visibility is bad. We can now remove these from consideration. We can do something similar to those points of cover that are in octants that are not visible. These are safe. At this stage we've determined the visibility of 6 of our points of cover without too much processing at all. The remaining points need to be considered one at a time, so let's do that now. A point of cover has a facing vector. This always points away from the obstacle. Getting the dot product between this and the vector to the enemy gives us a value of around 0.1. This is greater than minus 0.1, so this point of cover is visible, so it gets a score of 1. Minus 0.1 is a field of view value that you can tweak, but we found this to be about right. Repeating the same process with the next point of cover, you can see this has a dot product value of minus 0.9, meaning it is not visible. But as it's not 100% safe, we need to reflect that somehow, and this is done by adding the dot product value to 1, which gives it a score of 0.1. Remember, 0 is the safest it can be, so this is pretty safe. Right, on to the next one. This one has a dot product value of 0.35, which is greater than our field of view value of minus 0.1. So this is set to visible and given a score of 1. And the final point has a dot product value of minus 0.6, which means it's not visible, but it's more visible than the previous point of cover we assessed, which makes sense looking at where the bad guy is positioned. So we now have all our points of cover scored. The last thing to do is for our agent to find cover. So it finds those intelligent cover objects within range, and then requests the lowest and closest point of cover to use. Alternatively, the agent could request a list of safe points of cover, and it can decide which one it wants to use. This has been Game AI Uncovered. Thanks for watching. Before I sign off, if you have an interest in game AI, check out these books. Artificial Intelligence in Games will get you up and running with step-by-step code guides, and the Game AI Uncovered series is filled with insight from professionals about how they did the AI for the games that you love.